If you're running production workloads on GCP without Cloud Armor's adaptive protection, you're basically leaving your front door wide open during a hurricane and hoping nothing blows in.
That sounds dramatic, but I've heard DDoS attacks are getting more sophisticated. What makes Cloud Armor different from just throwing more servers at the problem?
Hey everyone, welcome back to the Network Ninja CloudCast. I'm your host, and today we're diving deep into GCP Cloud Armor's DDoS protection with my co-host here.
Hey everyone! I've been getting a lot of questions about this topic, so I'm excited to dig in.
Perfect timing because I just helped a client who was getting hammered by a Layer 7 attack that their basic firewall completely missed. They were bleeding money on autoscaling costs before we got Cloud Armor configured properly.
Okay, so what exactly was happening? Why couldn't their existing setup handle it?
Here's the thing. Traditional DDoS protection focuses on volumetric attacks. Think of it like a bouncer counting how many people are trying to enter a club. If too many show up at once, you close the doors. But modern attacks are sneakier. They send requests that look completely legitimate, just thousands of them per second, all requesting your most expensive database query.
So it's like having 1,000 people walk into a restaurant, each ordering the most complicated dish on the menu, and they all have valid reservations?
Exactly right. And that analogy holds up technically because each request passes your firewall rules, each one has valid headers and authentication, but collectively they're designed to exhaust your application resources. Cloud Armor sits at Google's Edge network, specifically at their global load balancers, and it inspects traffic before it ever reaches your back end.
Where exactly does it sit in the architecture? I want to make sure I understand the flow.
Great question. Cloud Armor policies attach to back-end services behind your global external HTTP load balancer, global external HTTP load balancer classic, or external SSL proxy load balancer. Traffic hits Google's Edge, which spans over 140 points of presence globally. Then Cloud Armor evaluates it against your security policies before forwarding to your backends. This means malicious traffic gets dropped at the edge, not at your VMs.
Got it. So what's the difference between the standard DDoS protection and this adaptive protection I keep hearing about?
Standard Cloud Armor gives you pre-configured WAF rules, rate limiting, and the ability to write custom rules using their expression language. You can block by IP ranges, like blocking all traffic from a specific CIDR block such as 203.0.113.0 out of 24, or match on request attributes like headers, paths, or query parameters. But adaptive protection, that's where machine learning enters the picture.
Machine learning for security? How does that actually work in practice?
Adaptive protection builds a baseline model of your normal traffic patterns over about a week of observation. It learns things like your typical request rates per client IP, geographic distribution, common user agents, and request patterns. Then it continuously monitors for anomalies. When it detects something suspicious, it generates an alert with a confidence score from 0 to 100 and suggests a rule to mitigate the attack.
Wait, it suggests rules? It doesn't just automatically block things?
By default, no. And that's intentional. You don't want an automated system blocking legitimate traffic spikes, like if your marketing campaign goes viral. The alerts appear in Cloud Logging and Security Command Center, and you can configure them to trigger cloud functions or pub/sub notifications. However, you can enable auto-deploy for high-confidence alerts, specifically those above a threshold you set, like 90% confidence.
What does one of these suggested rules actually look like?
Let's say adaptive protection detects an attack originating from a botnet. The suggested rule might look like this. It would match on a combination of source IP ranges, specific user agent patterns, and request rates exceeding a threshold. The rule uses Cloud Armor's custom expression language, something like evaluate pre-configured exploit with specific parameters, plus rate-limiting expressions. You can preview the rule's impact before deploying it.
What are the common mistakes people make when setting this up?
The biggest one is enabling adaptive protection without the baseline training period. People turn it on and expect immediate protection, but it needs that week of normal traffic data to establish what normal looks like. Second mistake is setting rate limits too aggressively. I've seen people set 5 requests per minute per IP, which breaks legitimate users behind corporate NATs where hundreds of employees share one public IP.
So what's a reasonable starting point for rate limits?
Start with your actual traffic data. Look at your load balancer metrics, find your 95th percentile requests per IP, then set your limit at maybe 3 to 5 times that. For most web applications, something like 1,000 requests per minute per IP is a reasonable starting point, but you need to tune it based on your specific patterns.
Let me make sure I've got this. Cloud Armor sits at Google's Edge. Standard protection gives me manual rules and rate limiting. Adaptive protection uses ML to detect anomalies and suggest mitigation rules. And I need to let it learn my traffic patterns before it's effective?
Perfect summary. And here's my pro tip. Enable adaptive protection in alert-only mode first. Let it run for 2 weeks, review the alerts it generates, and tune your baseline before enabling any auto-deploy features. This way you understand what it considers anomalous for your specific application.
This is really helpful. I'm definitely going to set this up in our staging environment first.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And share this with anyone running production workloads on GCP who hasn't looked at Cloud Armor yet.
Thanks for watching the Network Ninja CloudCast. See you in the next one.